Right. So I've been doing 2025 pyramids exam paper. That was going to be May 14, 2025. So a student from a class actually sent it to me. This is it. Nice. Add my students have exam tomorrow. 2025 pyramids unit 1 paper 3. All right, so let's just work through this paper. Just finish class with our students for our exam tomorrow. So let's do this. All right, let's see what's about. First question. All right, so this polynomial function expressed with a factor, and these are made of -12 when divided by x minus 1. I'm going to show that p equals 1, q equals -7, right? This kind of stuff. So since this is a factor, means that f of -2 is equal to 0. That 1 here, so I need two equations. So this is equal to 0. This is what was the first equation. What does that mean? That we are substituting -2 here and in there. The result equals 0. So -2 cubed is -8, so that's -8p. -2 times q is -2q minus 6, and that is equal to 0. That's the first equation. This can also actually be simplified by 2 and become -4p minus q minus 3 equals 0. We have divided by -2 actually, the value is positive. Then it is. Let's look at the next one. So the remainder is -12 when divided by x minus 1. That means that f of 1 is equal to -12. That's going to give us a second equation. That second equation, now that we're probably the one inside here, inside there. That's going to give us p plus q minus 6 equals -12. And so these two equations that we're solving now, and you can eliminate the q by adding them. Adding those two equations. We must add these two equations now. Solving them simultaneously. So adding -4p and p gives us -3p. These two wipe out each other. This is -9. 0 and -12, -12. When this -9 comes over, comes a +9, we have -3p, gives us negative, comes from a +9. So we get +9 and -12 is -3, divided by -3p equals 1, which is what they said. Then note, find the q, you can take this one and substitute it right here. To get to something like and 1 plus q minus 6 is equal to -12 from this equation. So this is 1 minus 6, that's -5, 2 equal -12 plus 5. We transfer -5, 2 equals -7. Therefore shown. Equals 1, 2 equals -7. Nice way to start that exam paper. You know that your first question is correct. 8 marks. Wow. All right. Let's continue. Next part will determine the other two factors. To determine the other two factors, we are going to have to basically divide this now by the one factor that we have. So P equals 1 and Q equals -7. The f of x is really, this P is 1, so it's really x cubed. Q is -7, so that's really -7x minus 6. And then x plus 2 is a factor. So I'm going to copy this down onto the next page. I want to divide by it. All right. Copy that down here. I want to divide it. All right. So I'm going to divide that by the factor x plus 2 factor. Find what other factors are. One of the x plus 2. And then we want to put all the order of the x. So there's no x squared in here, so I'm going to put 0x squared, so x cubed plus 0x squared minus the 7x minus 6. It's kind of important to put this in there and put like terms under each other. So it's x cubed divided by x is x squared, and x squared times these, giving us x cubed plus 2x squared. So we have x squared terms under each other. And then we are subtracting these. And so these are eliminated. So it's 0 minus 2, that's a negative 2x squared. And it's minus 7x comes down here, and minus 6. It's this divided by that, by this. It's a minus 2x. Minus 2x times these, giving us minus 2x squared, and minus 4x. Again, subtract one of the space that is smaller. Smaller and zoom in. All right. So this now is minus becomes a plus. So it's plus 4x minus 7x, that's negative 3x. Negative 3x. Minus 6 coming back on here. And it's a minus 3 divided by x equals negative 3. Negative 3x. Sorry. Negative 3 up here first. Then negative 3 times these giving us back negative 3x. And negative 6. And subtract all the getting 0. Because remember that's remaining. So the factors of this will be the other two factors. So we can just factorize these here. And factorize these now, and these will be the other two factors, and that factors out into x and 1 and 3. Signs are different, get the greater product, the minus sign. Greater product to the far one. Get that negative, this one positive. These now are for other two factors. Other two factors. That's the answer right here. Nice and easy. All right, let's continue. This question says, diagram below not drawn to scale shows a curve g of x. It's a rational function. X less than or equal to 0.5. And it says, on the same axis, we have to sketch and label the graph of the modulus of g. Modulus of g. Means that to get modulus of g, we just need to reflect this negative part of the graph over the x-axis. All right, now this part of it that is already above the x-axis will remain. So we will be starting here. Let's pick up some point on our foot. So this is going to stay where it is. This point is going to go to here. This is what? This is 2.5. Or the 2.5 right here. It's going to go there. This is right through this negative 1. It's going to come reflect up to 1 there. Just picking out some points. Then this point, which is negative 2, is going to reflect up to 2. All right, so just know that we're passing through these points. Reflecting points on this curve over the x-axis, all right? Try to get that accurate as possible. But this one is like 3, maybe not quite as 3, maybe around 1 and a small, or on the negative 3, it's about the same on the positive 3, maybe around here. And then we go up to about this intersection above there, which looks like will be around here. So I just want to draw the smooth curve to those points. Remember, this part of it is included. So I'm going to go like this. Then this will be a part of it as well. But that part, not that part. All of what I put in red will be the modulus function. So this will be the modulus of function. Because all the parts that are negative, they become positive. That is nice and easy. Good enough. All right? But this logarithm is the part of it as well. That is a 3 marks to that. Nice. Nice so far. Nice. This gives us function of x. And it's on R, not including 0, mapping to R, meaning on the set of real numbers. So basically, we know that x cannot be 0. Cannot be 0 compared to this 3. So x is a member of R, but not including 0. Something like that. The first part says by providing a proof or a counterexample, determine whether f is injective. Remember, injective means 1. So we can do the 1-to-1 test. Right? We're going to test f of A equals f of E. A equals f of E. Where A and B must fall under those conditions. So A and B have to be real, not 0. All right. Now, what you want is for A equals B to the B only solution. That is the case, then the function is 1. What is f of A? Then we put in A here. So f of A will be 1 plus 1 over E equals f of B will be 1 plus 1 over B. So these two wipe out to each other. We're left with 1 over E equals 1 over B. And if you cross multiply, or if 1 over equals 1 over B, then it's clear that A equals B. That's the only solution. Only solution. Which means that f of x is injective. That's the answer. Determine whether it is injective or not. This is the answer right here. 4 marks for that. Surjective. Yes, if it is surjective. I want to do the surjective test. Calculation method. For the surjective test, we test f of A equals B. And we're searching for a B that is in the codomain. That is not the image of an A in the domain. So the A again has to be real, but not 0. The B knows the codomain value, which is just real, right? But they said the function maps these real values, not including 0, onto real numbers. So the B is real. All right. So what will be the f of A in this case? F of A will be 1 plus 1 over A. That is equal to 1 plus 1 over x is the function. and that is equal to B. So the method now is to make A the subject and then try values to try to see if there are any value of B that will basically create something that is inconsistent with this condition. Right? A has to be real, cannot be zero. So one of the transpose and make A the subject. All right. So I'm going to transpose this one over here first. I want to get 1 over A equals E minus 1. Then to make A the subject, I can take the reciprocal on both sides. And so A will be equal to 1 over B minus 1. And voila. B cannot be 1. B is 1. A is going to be undefined. So I'm going to say, or B equals 1, which is a real number. So it means that 1 is in the codomain for B. The A is not defined, or is not real, not real. It's not defined. Because we cannot work out, this becomes 1 over 0, right? If B equals 1, it becomes 1 over 0. So the A cannot be worked out. So in that case, it is contradiction to what we have up here. That the A has to be a real number. So the A is not defined when the B equals 1. Therefore, f of x is not surgically. There's no value of A. There's no value in the domain mapping out the codomain 1. All right, and it can literally prove it up here to put this equals 1. So if you put 1 plus 1 over x equals 1. To try to find what that x value is, you have 1 over x equals 0. And you can't solve 1 over x equals 0. But if you try to cross multiply, for example, you still have a solution. 1 over x just can't be 0. All right, so you still have a solution. That kind of proof as well. So that is so it is not surgical, not surgical. That is that. But subjective also means untrue. All right, just as always say, injective also means 1 to 1. 1 to 1. Right. That finishes that question. Nice and easy. Question 1 done. Question 2. So it says B, M, and N are positive numbers, positive real numbers. Given that log of B, log of 3 to base B is M, log of 4 to base B is N. Show that this thing is equal to that. All right, well, I will have to take this left side and break it down. Right? So left hand side would be when I break it up from now. Well, this square root means half to the log to base B of, but that can square each of them. You can square each of them and become the square root of 27 over the square root of 16. So it really, both can have this 27 is a perfect square. All right, so let's do this here. Let's write as 27 over 16 to the half. Well, this is a square root. That's a square root. I'm not thinking I need 27 is a perfect square. Now I'm going to bring the half to the front. So we're going to get half log the base B 27 over 16. And then this now, when have this division, we can break it out into a difference. So we get half into log of 27 minus the log of 16, both of them to base B. Now we're keeping an eye on these, number 1, 3, and 4. But that's what we know. Although what a space. I'm going to reduce this side of this word. Reduce the side on this word. Alright, so what happens now is that this 27 is same as 3 cubed. And this 16 is same as 4 squared. All right, so it's gonna become half 3 cubed. 3 log to base b of 3. But this was 3 cubed, and this 3 comes to the front. I don't want to skip out any step, you know. Let's not skip out this one. Log to base b of 3 cubed minus log to base b of 4 squared. 16 is 4 squared. These numbers come into the front now. So it becomes half into 3 log to base b of 3 minus 2 log to base b of 4. We can make these substitutions now. That told us about log to base 3 of 3, log to base b of 3 is m, so m coming right here, and n coming right there. All right, and space is limited. It becomes half into 3n minus 2n. And if you expand the half over, to expand this half over these two terms, it becomes equal to the right hand side. Becomes equal to the right hand side. So equal to the right hand side. To expand it, all right? That's right. Well, become the same thing to the right hand side. Next one to let's solve this equation. And notice these are different. So, all right, so since this is base 2, I can change, I'm doing both of them to the same base. All right, and let's change everything to the same base. From brand new base, I work with a brand new base. Let's bring everything to the base 4. All right, so I'm gonna bring this to the base 1, this to base 4. Let's change the base of everything. I'm seeing other ways to do it, but let's just change everything to this. Change this to base 4. Becomes log to base 4 of m over log to base 4 of q. Log to base 4 of q. Plus this now becomes log to base 4 of 16 over log to base 4 of n equals 4. All right. If I'm doing it in a way that is not so very friendly, but this can work with the value. This can work with the value. Understand this is the same. The quadratic, the hidden quadratic in there. I was looking at the shot. I can't proceed this way, but I'm just thinking of maybe, another way, shorter way. This is another way. Let's do another way. I'm going to keep this one. Keep that. Now let's write out log to base 2 of m. The funny thing about logs and tricks, and you usually have multiple ways to do the distance. Plus, I'm going to first write this as 2 to the 4th power, log to base n of 2 to the 4th power equals 4, and 16 is 2 to the 4th power. And this 4 is going to come to the front. I'm going to have log to base 2 of n plus 4 log to base n of 2 equals 4. And this now can use the reciprocal law and logs. Well, it's a change of base last, but it goes like this. Log of a number to a base is 1 over log of the base. Log of the base to the number will come to this. We can do reciprocal with that. So this becomes log to this 2 of m plus when this does reciprocal multiplied by 4 over log to this 2 of m equals 4. When I multiply 2 by this, I'm going to get a quadratic. Multiply 2 by this. So I'm going to get log to base 2 of m all squared. Perfect now. I'm going to multiply this as well, but I'm going to transpose it. So I'm going to get minus 4 log to base 2 of m plus, and then when I multiply this by it, I'm going to go to the 4 equals 0. Yep, that's a perfect quadratic, perfect square. So perform the log to base 2 of m minus 2 or squared equals 0. That's a perfect square. To factorize that, it becomes that. So this square becomes irrelevant as square of both sides is 0. There's a repeated root. We're going to get log to base 2 of m equals 2. Log to base 2 of m equals 2. That's repeated. Perfect square. Got it from here now. We get m equals 2 squared, which is 4. That's the answer right there. Maybe I took too much steps, but that's all right. Next one. This one says use mathematical induction to prove that this is ruled by 6. Come on, this one. I'm gonna see. Let P is such that if this is given by 6, it is equal to 6 times some quotient. 7 to the n minus 1 is equal to 6 times some integer. So I'm gonna say n is a natural number, but the x is an integer. Then the first step is to show if it is true for n equals 1. So for n equals 1, this becomes 7 to the 1 minus 1, which is actually 6. 6 times 1. But it becomes 6. So therefore, it is true for n equals 1. So P1 is true. Equals 1. So P1 right here is true. So P1 is true. Next step in the proof is to say it is true for n equals 3. For n equals k, the statement up here from 7 to the 3 minus 1 equals 6 times some quotient. Define this quotient as an integer. And the n is a k, n is already defined as a natural number. K is a natural number as well. And here we assume that pk is true. Now, in doing step 3, which is the induction phase, I'm going to view something from the substitute here. From experience and practice, we know we can make this a summary. 7 to the 3 is equal to 6q minus 1, and we'll be able to make the substitution in the next line. All right, and so in step 3, we're going to go for n equals k plus 1. So step 3 is for n equals k plus 1. This thing up here becomes 7 to the k plus 1 minus 1. We don't write anything with 6 in there to prove it. We're going to split this up. And that becomes 7 times 7 to the k minus 1. But this works up into that. This is 7 to the 1. And then this substitution now, we drop inside here for that 7 to the k. So we end up getting 7 bracket 6q minus 1 minus 1. Then now we'll break this out. I'm going to get 7 times this 6 cubed, but to show the multiple of 6, I'm going to write this as 6 times 7q instead. I want to see the multiplying factor of 6, a multiple of 6, and then 7. 7 times negative 1 is negative 7. No, it's supposed to be a plus mistake. It's supposed to be a plus. All right, so that's a plus, that's a plus, that's a plus. All right. So 7 times 1 is 7. 7 minus 1 is 6, that's a plus 6. You see, we're multiplying factor of 6 into 7 cubed plus 1. Because q is an integer, this is an integer. Therefore, it means that pk plus 1 is true if pk is true. Why is that? Because we use result of pk including pk plus 1. Now we come to the last line, which is the conclusion. Therefore, by mathematical induction, the original statement that we call Pn of here is true, it will be true. It's true for all n which are natural numbers. That is for that. 9 marks. Wow. 9 big ones for that. Next one. This one says the binary operation to find out that. Now to calculate 8 star 27. So 8 star 27 becomes mean that the x is 8 and the y is 27. So it becomes 8 to the 1/3 plus 27 to the 1/3. That's all being cubed. So 2 to the 1/3, 8 to the 1/3 is 2. 8 to the 1/3 like cube root of 8 is 2. Plus 27 to the 1/3 like a cube root of 27, which is 3. That's all raised to the power 3. This inside there is 5. 5 cubed is 125. That's the answer. 125. This part says, show that star is commutative. So to show that star is commutative, show that x star y is same as y star x. That's all we show. Let's do it. So we're going to start with, we have x star y already. I'm going to flip it from now on, right? Y star x. Based on the definition of star, y star x would mean that when doing the y, x becomes 1x. So it could be y to a third plus x to a third or cube. This addition operation is commutative. Addition is always commutative. Addition of real numbers always commutative, right? Because it operates on a set of real numbers here. So let's write that over here. And let's say this addition is commutative. On set R and a set of real numbers. All right. Because that is commutative on the set of real numbers. These are all real numbers. We can switch these two around. Simply write this and this. X to the third plus y to the third cube. This right here is actually x star y. So we're showing y star x, x star y. This is that. And therefore star is commutative. Nice and easy. 2 down, 4 to go. Next question, going into module 2. The circle has this as its center and passes through this point. This is like an advanced level work. Advanced level question. It says determine the of a circle. First, we need the radius. So remember, for the field of a circle, this is the center. We're going to use this value as our A, and the 3 is our B, and we need the radius. We want to find the radius distance between these 2 points. So we need the radius. So the radius of the circle R is equal to AB, which is the distance between these 2 points, which is the square root of the difference in these two x values squared, which is 3 minus 1 squared, plus the difference in these two y values, 7 minus 3 squared, which works out to be, so this under here is 2 squared, plus this is 4 squared, 16 now 4 is 20. Square root of 20 units is the length of that thing. See that here? Very easy paper. And since you know the A, the B, and the radius, right, this piece of a circle is x minus a squared plus y minus b squared equals the radius squared. In the future, here the A and the B. So this is x minus 1 squared plus y minus 3 squared equals the radius squared becomes 20. R equals that, right? The radius squared is just 20. So that is the equation, right? 4 marks, and that's an easy. Show that the equation of a tangent at the point A is this. Like this proof questions. So it's like we have the circle and we have the center that we know is 1, 3. And then we have a point at A right there. And the normal is always the best friend in doing these questions in for normal. But the question really wants us to find the tangent line going here, which is perpendicular. That's a point A, which has coordinates 3, 7, 3, 7. We're really trying to find this tangent line. But the normal is going to help us. Why? Because the normal passes through the center and the point of tangent. So the gradient of the normal, the difference in y over the difference in x. So 7 minus 3, the difference in y, over 3 minus 1, the difference in x. Minus 1. That becomes 4 over 2 or 2. And so the gradient of the tangent minus 1 over the gradient of the normal, which is minus half. You want to use this gradient at this point to get the gradient of that rectangle. The equation of the tangent. I just write tangent is tangent. Y minus y value at A equals the gradient of a tangent into x minus x value at A. With y minus the y value at A is 7, and 7 equals the tangent gradient is minus half into x minus x value at A is 3 right there. 3 right there. Working towards. So we'll multiply across with this 2 and get 2y minus 14 equal multiply start there with this minus x plus 3. The take this and transpose over this side, get 2y, which is here. This minus x comes over becomes a positive x plus x. This is minus 14, and then do 3 more and subtract that, we get minus 17. That's all equal to 0. And that has been shown to be true. What? This looks like it was a nice, easy paper, guys. A nice, easy paper. This one said, determine the point of potential of parabola. And then, wow, solving simultaneous equation of a quadratic on a line like that. And they are friendly because you have minus y and y. Just need to add them. That thing. This one, the equation with y as a subject would be y equals minus 2x minus 3. But as they are now, we can add these two equations. We're just going to add them. When you add them, we eliminate the y. So adding everything on the left side, our x squared term is written there, and our x squared term minus 3x and the plus 2 is minus x. Minus 5 and the plus 3 is negative 2. That's said negative 1 and y cancel each other. That's all equal to 0 plus 0, which is 0. With a nice simple quadratic that factorizes without a thought. X, 1 and 2, stands are different, minus plus. So if x equals negative 1, x equals 2. When I plug these values now, that to get the corresponding y elements, we're going to say, and for this one, y is equal to minus 2 times minus 1 minus 3. That becomes a positive 2. So negative 1. So the y is equal to negative 1. So 1 point is negative 1, negative 1. And for this one, when I get the y, well, this is given to this middle. This one is here. This one is going to give us y equals minus 2 times 2 minus 3. Y equals negative 7. Negative 4, negative 3, negative 7. So, solution. Right? The question answers for the point of intersection, right? So 1 point is minus 1 minus 1 from here. And the other point is 2 negative 7. 2 negative 7. That's something. That's like C-sec. Simultaneous equations. Oh my goodness. Oh my goodness. So easy. So I did that. It's crazy easy. I'm not hearing myself. Wow. Wow. And they gave 7 marks for the Sabbath time. You know, they don't give so much marks for Sabbath time at the equation like this. You know, they don't give more than 3 marks. And you guys got a break this year with these questions. Well, paper from here still. Yeah, let's start to them. Vectors. This one says 2 vectors are OA and OB. I'm going to start with the modulus of AB. So I'll find the vector AB first. So the vector AB is OB minus OA. Both and last minus both and first. It's going to subtract them. So this one minus this one. So it's 2 minus a negative 1 gives me 3. 0 minus 1 is negative 1. 5 minus 3 is 2. Therefore, the modulus of AB becomes the square root of this squared, 3 squared, this squared, 1 squared, and this squared, 2 squared. Equal. Now this is 9 and 1, 10 and 4, 14. That's the square root of 14 units. Is a modulus, the magnitude of that. That is the AB. So determine the angle between the vectors. The angle between the vectors, remember now, is theta is cos to the minus 1 of a scalar product was calling A dot B. One modulus product, modulus of A and modulus of B. With the A, I'm going to use that as the vector OA, and the B is the vector OB. What were they at? So A was minus 1, 1, 3, minus 1, 1, 3, right, that vector minus 1, 1, 3, minus 1, 1, 3. And the B is 2, 0, 5. 2, 0, 5. We're just using them here. So theta equals cos to the minus 1 of the scalar product. Multiply these two values first, we get negative 2. Multiply the second values, we get 1 times 0 is 0. Multiply the third component by the third component, 5, 3, 16, 3, 5, 16. Divide that by the modulus of this one first, is the square root of 1, 1, 3, 1 squared, 1 squared, 3 squared, 1 squared, 1 squared, 3 squared. 1 squared, 1 squared, 3 squared. Then modulus of B, this one. That's 2 squared, 0 squared, 5 squared. I'm just going to put that all in the calculator and I put one number. I'm not going to work it on stages. Then I have a calculator. Just put this in like this. I'm going to leave it in degrees. So I'm going to do cos to the minus 1 fraction. So here is 50 minus 2, that's 13. Divided by the square root. Oh, that's what now. That's what this is 9 and 1 make 10 and 1 make 11. Square root of 11. Square root of 11. Okay, I multiply this on the same square root. Square root times square root of the same square root. This one is 25 and 4 make 29. 29. 43.3 degrees. 43.3 degrees is the answer. Nice and easy. Nice and easy. Nice and easy. 6 marks for doing those 3 lines of work. Wow. What? It's just done 4 already? All right. Now prove. Prove that this equals that. Easy. Over under. All right, we know say this is sine alpha over cos alpha, right? So that's what we're working towards. All right. So the left hand side of this equals. Now this cos over angle can move in 3 ways. And we're using it that is favorable. So the one that is going to subtract a 1. All right, so I'm going to subtract a 1. So remember the cos 2 alpha, remember that's 2 cos squared alpha minus 1. Or it can be 1 minus 2 sine squared alpha. Or it can be cos squared alpha minus sine squared alpha. Now based on this, we want to be subtracting a 1. We have 1 minus something. So based on that, we want to be subtracting a 1. So we're going to be using this one. So we can subtract this 1. Alrighty? As we use this one, it's going to be a minus and we're adding a 1, right? So I'm using that one. So it's going to become 1 minus. And then this one, I'm using that. Put that in the bracket. 1 minus 2 sine squared alpha over, I mean, this double angle now is 2 sine alpha cos alpha. When you know it, you get, when you know it, you get this on your head, questions are much easier to do. This one minus this one that is eliminated, and then minus this negative 2 sine alpha is going to be positive 2 sine squared alpha over this 2 sine alpha plus alpha. Then you shall see that 2 cancels 2. Sine alpha cancels one of the sine alpha. I'm going to put sine alpha over cos alpha, but I don't like the one alpha door. I'm just going to write it. So this now becomes sine of alpha over cos of alpha, which everybody knows that is tan of alpha, which is the right side. Quite easily brushed aside. Quite easily done. All right, nice and easy. This one says, but to solve this equation, that's equal to 0. It's going to factorize the tan. And we'll go in a negative range. All right, so to find angles in a negative range, we find angles in a positive range first, and then subtract 2 pi, which are these positive angles. That's just the easy way to do it. All right, so this equation is going to become factorize the tan x. So going to be tan x into tan x minus 1 is equal to 0. So this factor gives me tan x equals 0. This factor gives me tan x equals 1. Nice numbers. So I now can now draw the quadrant diagram for this one where the tan treat 0 as a positive. So tan is positive here and there. The principal angle alpha for tan to the minus 1 of 0 is 0 radians. Over here, quadrant diagram again, that's a positive 1. So tan is positive here and here. Then now the principal angle alpha, tan to the minus 1 of 1 is further apart with pi by 4. More things you know the better. Pi by 4. All right, can look at it over here. Change the calculator into radians. And then if you do tan to the minus 1, where is it? Of 1. Get that value. Look at it if you want to see pi by 4 right there. There you go. Who needs to go to the calculator when you can know these things in the head? Certain things, the more things you know, the better. Then now, remember, this quadrant over here is your pi plus alpha quadrant. Same thing here. Pi plus alpha. This is your alpha quadrant. So let's put out the values, then put out the negatives as well. So for 0, you're going to get the x from this equation where the x is equal to on this side. The x is equal to 0. And this quadrant is going to be pi plus 0, which is pi. Then now, to get the negative angle, we take this minus 2 pi. So you get negative 2 pi. And then this minus 2 pi, negative pi. Did I write those out? Right. So the first two values, 0 minus 2 pi, so get the negative angles. And pi minus 2 pi. All right, so let me get the sheet so what's up. To the right over there. All right, so the angles over here are 0, pi, minus 2 pi, and minus pi. If you look at this range, minus pi is not included, so the e is not equal and the equality. So based on that, this marker we can accept. Based on that, you can accept 0, you can accept pi, you can accept minus 2 pi, you can accept minus pi. You have to be between pi and minus pi, so you cannot include that. Well, this side, looking pi by 4. So here now, the x, so here now, your x will be pi by 4 itself in the first quadrant. And here the I plus 5 by 4. That was minus over here plus I plus 5 by 4. Right? And then now to get the negative angles, now going to subtract, right? Well, this works out to be 5 by 4. Right? And 5 by 4. This is really, this is 4 over 4. It's 5 by 4. So it's actually 5 by 4 right here. So to get negative angles, take this and subtract 2 pi. So it's 5 by 4 minus 2 pi. And then this the same thing, subtract 2 pi. 5 minus 5 by 4 minus 2 pi, 5 by 4 minus 2 pi. Get the negative angle. Let's work over there. So x equals this 5 by 4 stands. This is 5 by 4, which is actually inside the ring, but this is 1 1/4. That's 5 by 4. We're going to write a solution. And this one, this is same as 8 over 4. 2 pi same as 8 over 4. So 5 minus 8 is negative 3. That one becomes negative 3 pi by 4 minus 3 pi by 4. That's what is to show. Minus 3 pi by 4. And this one, this is same again as 8 over 4. That 2 is same as 8 over 4. That's negative 7 pi by 4. So that will be negative 7 pi by 4. We can mark the ones that we can use, right? The ones that are within this range. They gave us 85. This one is in there. This one is 1 1/4. So this one is not in there. This one is in there. 3/4 negative. This one is not in there because negative 1 3/4. Right? So this one is in there. This one is not. Now we can write a solution. Solution line. Put them in a solution. X equals smallest value is this negative one right here. Minus 3 pi by 4. And then 0. And then 0. And then this 5 by 4. So that's 5 marks for that. There you go. Something that's an easy question. That's a lot of marks for that. Don't forget that one. Some people a little bit more than I thought it would. Minus 3 pi by 4, 0 and 5 by 4. That's a solution. Next question. In that just you can not show that. But let us show that question on this exam. Show that this thing equals that. So I'm going to show it now. What I want to do is say something like A cos theta plus, not plus, minus, minus. And just give them the form result as minus B sine theta. It's going to be R cos. Going to be R cos. Actually, it's equivalent. R cos of theta plus alpha. Element R, so that R is equal to the square root of A squared plus B squared. And the alpha is always tan to the minus 1 of B over B. This is a form result for this. So this question up here, let's write it. A is equal to root 3, that's equal to root 3. And the B is equal to 1. Whatever sign is 1. All right. Therefore, we can say this is the R. Notice what I'm not just now. Let's put them right to some. Let's just put them right to it. Let's just put them right here. So this will form the square root of root 3 squared. Root 3 squared. plus 1 squared. That becomes 2 because this is actually 3 plus 1 is equal to 4, which is 2. That's what I want to write here. And then this calculation now becomes 10 to the minus 1 of b, which is 1 over root 3. But 10 to the minus 1 of 1 over root 3 is 30 degrees or pi by 6. And you think you know the better. See, put in the calculator. 10 to the minus 1 fraction 1 over root 3, 1 over the square root of 3, same as root 3 over 3. You're gonna get pi by 6. There you go. All right. So what it means then? It means then that your g of theta is actually equal to this. This is going to prove it by giving this information. So g of theta becomes 2 cos theta plus pi by 6. I've shown how I got mine. R alpha. All right. So hence otherwise determine the general solution of G. General solution of G. I think then G equals 0. General solution of G equals 0. So we're going to be put this expression equals 0. All right. So hence otherwise. We use that. I would put this equals 0 as well, and let's divide our form. But I said, hence would be us using this result. Otherwise, it would be us using hand by changing it to interesting to see what it was in more ways. 4 marks. Now I put this equals 0. Hence method usually is a method. So I'm like 2 cos theta plus pi by 6 equals 0. Going to by that 2, so the cos of theta plus pi by 6 still equals 0. The general solution is that the theta plus pi by 6 becomes cos to the minus 1 of the 0 plus 2 and 5. You have to say is an integer. You have to say this. Now, cos to the minus 1 of 0 is pi by 2. More things you know, the better. Right? So I can put my pi by 2 for that. It's actually plus or minus on a wall. The solution for cos is plus or minus. Don't give it away. It's so short. It's plus or minus. By the first and the fourth quadrant. Plus or minus. Yep. I'm going to transpose this pi by 6 and make it negative. So the theta is going to be negative pi by 6. Become plus or minus pi by 2. Yep. Plus this 2 and 5. Where n is an integer. That is it. But I advise you to do it this way. Doing it this way, and do it in a more massive but better ones. My speed got right in your sound, zoom in on it. Right, it's small and red. So we're solving root 3 cos theta root 3 cos theta that minus sin theta equals 0. So otherwise method no, right? But to solve this one, divide by cos and form tan. Divide both sides by cos and put that in power. Divide by cos and form tan. So divide this by cos theta, divide that by cos theta. Divide this by cos theta as well. And then what would happen is that this will become root 3. This will become tan. So it's 0. So getting tan theta equals root 3. The general solution for tan is what again? The general solution for tan. The solution but sine is two parts. You have a solution for plus or minus or the n power one. So theta is tan to the minus 1 of the 3 plus n pi. That is it. Plus n pi. And root 3, 10 to the minus 1 of root 3 is what? 60 degrees. Yes, it's 60 degrees of pi by 3. 10 to the minus 1 of root 3. Pi by 3. So this one would be theta equals pi by 3 plus n pi. N is an integer. N is an integer. So the question is, are these two solutions the same? Are those two solutions the same? So, all right, you can test it anyway. You can actually test it and see if those two solutions will be the same and they give us the same answer. All right, so when n equals 0, it becomes pi by 3, right? The question is, can this also be pi by 3? And that will be pi by 3. What happens when you pi by 3? Let's try to avoid that. If we put n equals 1 up here, it will be pi by 3 plus pi, which that will be 3 over 3, which will be 4 pi by 3. You want to see what happens when we make this 4 pi by 3? Put it equal to pi by 3. So minus pi by 6. So minus pi by 2 plus 2 and pi equals 4 pi by 3. So what it will be? Then we come out to the integer. That will make it true, right? So first the pi's cancel, so I can drop out the pi. I'm just testing it, guys. Just testing it. Another part, just in one to one size. That's a half. And drop this pi as well. Right here. And drop that pi. And then I can divide by 2. Divide by 2. Can build up this, make that n. So if I divide 2 by this 2, this becomes 3/3, this becomes a quarter, becomes 1 over 12. 1 over 12. And so the n, well, I can take this minus and going to by here, and make it become plus 1 over 12. Let's see if I'm putting an integer for the bottom, right? And so 1 over 12. Now this one is same as 8 over 12. This is same as 8 over 12. That becomes 9 over 12. And over 12. And then this quarter is same as 3 over 12. The same as 3 over 12. 3 over 12. So the n would be 9 over 12 plus or minus 2 over 12. So you get an integer with a plus. And it becomes 12 over 12. The reverse is that integer. So you can see it works. So you get an integer by the parts. But anyway, you know what those two would be good. Right? So either one would be correct. You just start for different values of n here. You don't get different values. That will work. You get the same answer for different values of what the answers that they get will work. All right. So you know what these two things work. So this is the hence method over here. This is the hence method over here. And then it's the otherwise method. This is the otherwise method. Otherwise. Then too long on that. Let's continue. This one says, determine the Cartesian equation of the line whose parametric equation are these. What a question is. You basically just substituting out for the t, you know? Substituting out for the t. So for this one, you find the t and add it over and divide by the 6, the negative 6. So for this one, t is going to be x plus 5 over negative 6. And for this one, t would be y plus 2 over negative 8. And all I have to do is equate. I have the Cartesian equation. Equate them. This equals that. Or this equals that, whichever way. Y plus 2 over negative 8 equals x plus 5 over negative 6. These two negatives can be dropped. You cannot cancel each other. Multiply by negative 1. You can also divide both sides by negative 2. Right? Divide both sides by negative 2. It performs. Don't worry, that's against the right system. Yes, the title is 3 marks. 3 marks. 3 marks. Okay, this. The color of that. Right. And then we're working on this song. Well, I guess if you leave this as the answer, they give you mark. They give you marks. I am eliminated. Until eliminate here, the part of the equation. Just to simplify it, I'm just cross it out. But divided by negative 2 is going to become a negative 2 is going to become a 4, and it's going to become a 3. But divided by negative 2. Right? Now multiply both sides by negative 2, I should say. Multiply side by negative 2, multiply side by negative 2. Can I cancel that, right? And we're going to cross multiply next. So we're going to take this 3 multiply up here, and we'll get it. 3y plus 6 equal to this one multiplied up here. We will get 4x plus 20. So we can just transpose everything on one side. So let's put everything over here. So we get 3y minus 4x. And I subtract everything from the 6. We get negative 14 equals. That's it. That's that. Simplify. But I think once you reach here, you're good. Alright. So let's get that now. So a plane passes through these points. And it has a normal. I give it a normal. From the equation of the plane. Wow. I give it 3. Again, there are 3 points in the way. Once I have a normal. And one a vector equation. So that is r dot n equals a dot n. I'm going to use b. That means e is up by 1, 1, 1. So b dot e dot n. You can use any one of the points over. Any one of them. Give it the same answer. So the r dot n is 2, 8, negative 7. And here now, let's go to this point and the normal. Using 1, 1, 1. That's just easier numbers to work with. Dot 2, 8, negative 7. And so this should become 2 plus 8 is plus 8. And 1 times negative 7 is negative 7. That is 10 minus 7 is 3. So reduce for r dot 2, 8, negative 7. Negative 7 equals 3. See the answer? The answer is leave it or not. They'll give us a lot of information not necessary. What is true is that it could work. We could have used r dot n equals a dot n. If you do the scalar product with this, and the n going to be the same by the 3, you can try it for yourself. Or we could use r dot n equals c dot n. The scalar product going to be 3 anyway, I'm sure. Has to be. All right, has to be. So the scalar product with this and this going to be same by, let's do it. Minus 3 to 1. Minus 3 to 1. Scalar product with 2, 8, negative 7 will be negative 6 plus 16 minus 7. See that? This is 10 minus 7 is 3. And then if we did it at this point, it will be minus 2, 0, minus 1 dot 2, 8, negative 7. What would this be? This should be equal to that negative 4. That's that negative 4. That is 0. And then this is a positive 7. So this equals 3 and this equals 3. So anyone of you got the same thing. So this one would be a dot n, and this one would be c dot n. Let's see, anyone you do, I get 3 just the same. All right, so if we give away question, 3 marks for it. So we'll give anyone another question. Number 5. Find the limit. For this one, what we want to do is that the limit as x tends to 0 of sine of any number times x over the same number times x is equal to 1. If I have 3x here, I think that 3x are there. I'm going to do some algebra, some shifting around. Become the limit as x tends to 0 of sine of 3x over moving away this 2 out here. I'm going to put by the x on the there, and that 3 on it. I'm going to put 3 on it to get the 3x and 3x, but I have to put back 3 up here. That's what we end up getting. This part of it becomes 1 in a problem. This whole thing becomes 3 over 2 times 1, which works out then to be 3 over 2. 3 is the marks. Yeah, 3 over 2. This exam really easy. Really very easy. This one says use first principle to differentiate that part of the equivalence 3 terms. And do it term by term, then we do it all at once. Let's just do it all at once. Let's just do it all at once. All right, let's do it. So what is going to happen is that your dy by dx, or let's call it f prime. Let's call it function of f. Let's say f prime of x is the limit as h tends to 0 of 1 over h into f of x plus h minus f of x. Some teachers write f of x plus h minus f of x over h. I put the limit on that, right? Same thing. I like to have my h out the way. Remember, when you get rid of this h, you calculate cancellation or whatever, you're good to go. You can apply h equals 0 elsewhere. So the whole aim of differentiating from first, it really is to be able to eliminate the h that is here, this h. All right, so let's do this now. So this becomes equal to the limit as h tends to 0 of 1 over h into now f of x plus 8, we not put in x plus 8 where those x's are. So we're going to get 5 times x plus h squared plus 4 times x plus h. X plus h minus 2. That's what this is. Minus f of x is the same thing. which is just 5x squared plus 4x minus 2. Yes, we have balance. So this becomes equal to the limits as h tends to 0 of 1 over h into when expand. Expand this first and multiply each term by 5. I'm going to get 5x squared. I would have had 5 squared over 2, which is 2hx. Multiply that by 5, and you will get 10hx. And this one would have been given up like h squared times 5, which will be 5h squared. I'm going to expand this. I'm going to get plus 4x plus 4h minus this 2. Put this up now. I'm going to get minus 5x squared minus 4x, and then this minus makes like a plus 2. We have any space? Yes. Plus 2. All inside there. This becomes a limit as h tends to 0. 1 over h. Some stuff will start to disappear now. So this 5x squared cancels this 5x squared. Let's underline the one that will disappear. This cancels that. And then this 4x cancels this 4x. This negative 2 cancels that positive 2. So now I am left with just these 3 terms. Alrighty? That's 10hx, 5h squared, 4. Right, I'm going to do the word math. All right, so I'm going to 10 h plus 4h it's 5h squared. 5h squared plus 5h squared plus 4h. What happens now is that I'm dividing, this means I'm dividing each term inside it by h. So h will cancel this, cancel that, and cancel that, right? That's what this h will do. And so this whole expression becomes the limit. As h tends to 0. Cancel away this h, I get 10x. Cancel away one of that h, I get 5h. Cancel away this h, I get plus 4. Because I'm going to show myself h, I can apply h equals 0 right there. And I know that this opens up into 10x plus 4, which is what you get when you differentiate this thing. 10x plus 4. That is it. Do I leave those markings on these? Yes, I can leave them. That kind of shows how we end up getting mostly the symbolic elements. The symbolic elements. Let's put that down. It's not in red. That we kept those 2 things. Everything is underlined. It's gone. That is it. Yep. Done. 6 marks. Some gives us this complicated looking differentiate. Some people use the U and the V and R. I must want to differentiate it's true. Let's look at it. Well, that's a trig function. The function within a function. 3 functions in this, 3 different functions, 3 different things that differentiate them. 3 different things that differentiate. Differentiate the core of it. Differentiate what's in here. differentiate the sign. Then treat it like 2 terms, work like 2 terms. So that's another simple like a curve. That times that. Let's write this as a power function first. So it's gonna be that y is equal to x cubed. This now I'm gonna write it as sine of 3x squared minus 2 or to the power 4. Right? See, better that way. Differentiating now. dy by dx equal. I'm going to keep the first and differentiate the second. Keeping the x cubed as it is. I want to differentiate the second in a square box. Isolate. But to differentiate this now, I'm going to differentiate the whole thing first and equal x to the 4th power. We're going to go 4 times the same thing, and this power is reduced by 1. So the sine of 3x squared minus 2. Everything there, power is reduced by 1. Then I have to differentiate what's inside this bracket. But to differentiate the sine function, we differentiate this first, which is 6x. Then differentiate the sine function and get the cos function, which is the cos of the 3x squared minus 2. All I've done so far is get the first, differentiating this. So the differential of this is inside here. All right? One of the speeds. Plus, I am now going to keep the second function, which is this. Differentiate the first function. I'm going to keep the sine of 3x squared minus 2 or raised to the power 4. Multiply that by the differential of 3x, x cubed, which is 3x squared. That's it now, we're done. So we simplify, much more start, 5 months, let us simplify. So dy by dx becomes equal to this other one. So it's 6 times the square is 24. And it's x cubed times this x is x to the 4th power. And this is really sine cube of this expression. So it's sine cube of 3x squared minus 2 times this cos of the same function, cos of the 3x squared minus 2. That's just this first expression in that. And I'm adding this now. I'm going to put that second line plus becomes this times that. I put this power function back on here. So it becomes 3x squared times sine 4th power of 3x squared minus 2. I am not doing anything else, even like that. That is it. All right, that is it. It's kind of still sorted. A little bit more. That is it. I'm not doing anything else on that. That's it. 5 months. Moving on the column. So water is pouring into an empty right circular hole with a constant rate of 8 cm cube per minute. It's a dV, it's a rate of change, it's a constant rate of change. This expression dV by dt is 8 cm cube. No, time is in minutes. Time is in minutes. So the depth of liquid in the corner T and time T in minutes is x centimeters. This is x centimeters. This is the liquid, right? That is not the liquid. It says the angle alpha between the vertical height h, that's this alpha here, and the cone of the cone and the slant height, the slant height of the talking about this angle, is 10 to the minus 1 of root 2 over 3. That's 30 degrees, you know. All of this one. 10 to the minus 1 of root 2 over 3 is just 30 degrees. Now, this is just 30 degrees. That is 30 degrees. If you want to do the calculator, you see 10 to the minus 1 of 2 over 3, root 2 over 3 is 30 degrees. So why didn't you just say it's 30 degrees? It's 30 degrees. And that can also be written as this. So it means that tan alpha is root 3 over 3. You know? And root 2 over 3 can be simplified as 1 over root 3 to, you know. But you multiply this by root 3 over root 3. These two we cancel that one, right? So more things you know, the better. All right, so this is tan alpha equals that 1 over root 3. All right, it says, and the volume of a cone can be expressed as V equals 1 over x pi r squared. This is not 1 over x, 1 over 3. This is supposed to be a 3, 1 over 3. 1/3 pi r squared e to the volume of a cone. Students, we don't know this in problems. That's a 3rd pi r cubed and that's an x. You used to make too much mistakes all the time, man. Come on. It says, show that the volume VCM cube of water in a cone when the depth is x can be expressed as this in terms of x. I'm talking about the volume of the sphere of the distance. So only at this level, we need the radius. Put in this formula for the radius. The height is already x, this height is x. Now this h, you know, that h is the overall height. Talking about the volume here is x. All right, so the question is, what is this radius right here? We can find it because it tells us the angle there. So the tan of the alpha is opposite over adjacent. The adjacent is actually this at the x, and that's the radius. So the adjacent is actually h. Look at this right angle triangle here. So it's r over, not h is x. X. Right of water x is r over x. So when we put x up here, the r becomes x tan alpha. And tan alpha is this. Okay, this one, simple. 1 over root 3. So the r equals x over the square root of 3. So the volume that we want down here, volume of the water V, becomes 1/3 pi r squared. X is the height, not h. X. And r is this. I see this is in terms of x alone. So it's going to become 1/3 pi. Then the r is this. You want to put that in the square. X over root 3 squared times by this x. It works out because this root 3 squared is 3. 2 times 3 is 9. And 9.5 over. That becomes 1 over 9 pi, and then the x squared times this x of x cubed. X cubed. That has been shown. 4 persons recognize that they were trying to do the formula for the volume of cone is 1/3 pi r squared h. And the sad thing about that, they put the h on this formula. Anyway, on that diagram, and I put it on the same format, so I'm confused if you don't know what they're talking about. That is it. I'm not easy to do it, but never know. Anyway, that has been shown, right? And this is a connected rate of change question. So you know we're gonna differentiate this. Let's do it from now. So dv by dx. We're gonna ask for the rate of change of the height. Sure. It's gonna become this pi is gonna become a third. It's gonna become a third. 1/3 by x squared. That differentiate this. I know we're gonna do it. I'm gonna do it of change. It says calculate the root of which the height of water. This is actually for dx. Height of water is x now, dx by dt. That's what the question wants to know. Is increasing when the height of the water on the cone is 6. That is when x equals 6. What is this when x equals 6? Look how we're going to form a connected exponent. We're going to use a chain rule. So we're going to use a chain rule. So we're going to use that dx by dt is equal to the product of two roots of change. This goes on top of the first one here. dt goes on the bottom of the second one. And third variable that is changing the volume. I'm going to put it here dv and dv. Now we know this. We're given that. Let's put up here some. That is 8. We know that dv by dt is 8. And this now is the reciprocal of what we have up here. We have dv by dx, but here we need dx by dv. Let's write over here. So v by dx, dv by dx. Because this is a fraction, I'm going to reciprocal, I'm going to write this as a fraction. I'm going to write this as pi x squared over 3. See here, pi x squared over 3. So this now is a reciprocal of that. It becomes 3 over pi x squared. This is just reciprocal 3 over pi x squared. And then this is 8. Whereas when x equals 6. All right. So that's dx by dt. Is that so? When x equals 6. For what? This case here, lots. The dx by dt becomes is 24. 24 over 5 times 6 x is 6 squared. Which becomes what? This up here, so this is 36. So we have 24 over 36. So we can do that with 2 times, that with 3 times. It becomes 2/3. So it becomes 2 over 3 times this pi under here. And that's going to be centimeters per minute. But remember, the time is in minutes. And the radius is in centimeters. So that is centimeters per minute. Let's write it down. Centimeters per minute. Yep, that's the answer. Centimeters per minute. Over 3 pi. That is it. Leaving it at that. It's just 6A. So Brianna said, this question, 6A gave us some problems. All right, so it said, the mass of a population of a certain micro, triples every 4 hours. Every 4 hours. It triples every 4 hours, so don't know the rate. Our rate is always given per hour. And after 6 hours, the mass of the population is this. So that's why you can find some constant. Calculate the mass of the population of microbes at t equals 0. That's at the start. let's say note an integral of 1 over y dy is given by plus c. So we're going to integrate some reciprocal function like that. All right, so we don't know the rate of growth. I didn't give it as a percent. We know that the rate is proportional, is in relation to the mass that was there before. All right. So I use m for mass, t for time. All right. This means that the rate of change of the mass, dm by dt, is equal to some rate that we don't times the mass that was there before. But they give us over 4 hours, we can't use 4. We don't know what the rate is. All right? That's what we have to do. We don't know what the rate is. So R equals the rate of growth. Rate of increase. And it's given in terms of the mass. So that the mass triple over 4 hours, but we can't know exactly what the time the rate is from that information. All right, so we call it the rate at our don't know it. We know that after 4 hours, the rate triple. So this is the rate of growth. Or the rate of growth. All right, so over of the separate variables now start to establish a differential equation. I want to use this information that it was and plug it in there to find out what this rate is. All right, but we have to be able to put in the time of 4 hours. And we have to be able to put in starting mass. All right, and it's after 6 hours, the mass becomes 3.6. That's for us to find a constant as well. All right. So we're going to separate the variables. By this n, by this dt. So I'm going to get 1 over dn. M is the mass. M equal mass at time t. Finding those things, right? So we have R, M, and T expressed. So we're finding them out here. And then now, when I multiply the dt up here, I'm going to get R dt. I'm going to integrate both sides. Integrate this side and integrate this side. The helping us. The integral of this is ln m. That's the integral 1 over y dy and y using n. So it's become ln n. Ln n equals, this becomes RT plus some constant. Now, when you're working with logs, you want the constant to be a log as well. We'll call that ln, the mass at the start. ln, the mass at the start. Oh, no, the mass at the start. Because when t equals 0, ln m will be equal to ln n o. So this is the mass at t equals 0. All right. So we don't want to put c over here so that I'll put that easier. That comes through years of experience, guys. You're doing integral with logs with a constant. They put a constant and the log ln of some other variable. And this is usually the value at the start. But that's when t equals 0. I'm going to reduce simple expression. This is going to come over here and subtract. So once you get a formula for n, that's what we want. So we can plug in that when t equals 4, the population tripled, right? The starting population tripled. All right. Can be from now on about. Can be from now, but let's establish a formula for n by putting this over here. So we're going to get ln m minus ln mass at the start equals RT. So this becomes ln This becomes ln m over the starting mass equals RT. So this becomes e to that. So the mass over the starting mass becomes e to the r times t, which means that the mass of any time is the starting mass times e to the r t. This is the mass that the question asks us find out. Starting mass. Mass when t equals O. But based on the information, they say every 4 hours a triple, right? So after 4 hours, starting mass triple to 3n. So you can set up yourself. So at t equals 4, the mass became 3 times the starting mass. So we're going to make the substitution now in here. So this becomes 3 times the starting mass equals starting mass e to the t is 4, so you e to the 4r. E to the 4r, or the t is 4. The starting mass then cancel. And then we take starting mass to get 3 equals e to the 4r. We take ln of both sides. Ln this side and ln shift this over a bit. Ln the two sides. This comes to the front. And then the ln is gone. We're gonna get ln 3 equals 4r divided by the 4. So the r is equal to a quarter ln 3. We can actually work that out, but we're not gonna work it out. I'm not gonna get the exact value. All right, so that is the r. When we don't need to know, usually the m we want. So we have to use this condition now to say when t equals 6, the mass is 375. So based on that now, we have this formula that we're going to plug that in. There's the formula of the mass. This is the formula of the mass of this. This is the formula of the mass. I don't know what r is, right? That is the rate. So I'm going to use this up here now. Change the color of the curve. I'm going to plug the condition in there. So it says, remember, it's MO really trying to find a starting mass when t equals 0. It says, when t equals 6, the mass is 375. That's what's going to give us our MO. I will now know what the R is. We can plug that information in this. So it means that 375 becomes equal to the starting mass times e to the 6r. 6r, e will become 6. E to the 6r. E to the 6r. And that's what we're trying to find. Starting mass. We're going to divide by the e to the 6r. So the starting mass becomes 375 over e to the 6r. Now what is 6 times this? 6 times that, 6 times a quarter ln 3 becomes 3 over 3 ln 3. That's what the 6 are becomes. 3 over 2 ln, right? So the starting mass becomes 375 over E with 3 over 2 ln 3. So what our result is the answer for starting mass. I don't want to nice to start the paper so far. Sometimes experience helps you a lot. You don't know the system, it can be tricky to figure out on your own in an exam. I'm telling the truth. It can be tricky to figure out on your own in an exam. So no wonder Brianna said this one gave us some problem. It's a question like this already in 2015 and 2016. So that question is similar to this, exactly like this, I remember. 2015 and 2016, one of those years. So we're solving this thing down. So the initial population was sort of fraction. And we can test and see if our formula correct. Test it and see if it works. 375 over E raised to the power. No, this 3.2 over 1.5. 1.5 and then ln 3. Ln 3. 72.2. So 72.17. Now let's put 72.17 to get some accuracy. 72.72. 72.2. I am saying that this is the starting mass. So this I'm saying is the answer. All right, now we can test it, right? So that mass was tripled after 4 hours. That's what triple this for that way. Times 3. 216. So we can do, we can plug 3 into this and say we get 360. This is not putting 360. Let's try it. All right, let's try that. So I'm using this 72.2 as my starting mass. 72.2. People are going to triple 3 from 260 times E raised to the power. That's that T becomes 4, I mean 4R right here, right? 4R. So 4 times this becomes just ln 3. ln 3. Yes. Yes. Works. Now 3 times this is that. Works. Yep. Yeah, because e to ln 3 is 3. Yep. 3 times that. That is correct, Mr. Shaw. And let's try the t equals 6 in this same formula and see if we'll get there. But we're going to get the 375 and work backwards on this already. So it works. So that is it. So confidently, let's see yes, that's correct. Yeah, all right. At the basically take time with this system. And I different with a nice system. Then full marks for that. Down here. I'm on the last question. All right. This one says diagram alone drawn to scale shows a graph of y equals 8 minus. That's this one, x squared. And then y equals 2. With y equals 2. This is y equals 2. All right, so this is y equals 2 right here. Y equals 2. And then this is the curve, right? All right, so I guess I'm going on top here everything and something. All right. Y plus 1 the other curve, which is y equals 8 minus x squared. And they intersect here and here. And this graph is symmetrical about the y-axis. So this half of it, the same as this half of it, symmetrical. All right, that's what it says. Whereas volume requires calculate the volume of a solid of revolution generated by a revolving region bounded by the curve and the line about the x-axis. Okay. So we are revolving up inside here around the x-axis, right? So it's a volume generated by the curve minus the volume generated by the line. And it's up to this point where they meet. So we have to find the x value here. Where they meet. If you go by the graph, that looks like for half of it here, about 2.5. This is a graph, and this line up to get to myself. You can go by the graph. Right? You can go by the graph. So we have to solve these two simultaneously to find where they meet. Alright, so if I label these points A, B, that's the at A and B, this equals 2. So 2 becomes 8 minus x squared. So x squared becomes 6. See? So x equals plus or minus square root of 6. See, I'm going to quickly use that. Square root of 6 is about 2.5. Let's see. That looks like 2.5. Square root of 6. 2.45. See, almost 2.5. So that's why it looks so close, like 2.5. Well, this is actually root 6. And this is minus root 6. All right, so what we're gonna do, I'm gonna keep it simple. We're gonna find the volume generated by this section and half of it. And that's 1.5. So we're gonna work between 0 and 5/6. All right, let's work between 0 and 5/6 in this interval. We don't have to use the negative limits. So the volume generated by the backward, which is the volume generated under the curve, minus the volume generated by under the line. Now remember, volume now, we will square these things in. But volume, remember, is pi times the integral of y squared dx between the limits. So this is y, one of the lines. For this one, the y squared is 4. For the curve, this is for the limit. So this is the curve. This is the curve. This is the line. So for the curve, the y squared is going to be 64. Then twice birth of 2 is going to be what? 16 minus 16x squared. And then this square is going to become x to the 4th power. All right, let me shift this down a little bit. Shift this down a little bit. For the line. And this part is for the curve, this point on the curve. All right. So the volume generated is 2 times the volume generated by that purple unit, which is the integral between 0 and root 3 from the curve minus a line. That's what we're going to do. So the volume required becomes 2 times volume by the curve minus volume by the line by curve. The curve will give a bigger volume minus the volume by the line. We're talking between 0 and √6. All right. Remember, volume now is pi times y squared, or the y squared terms up here already. All right. Now, we're going to do the curve minus the line. So the curve minus the line is going to be, it's going to be 64 minus this 4 given 60. We subtract them. And the same limit between 0 and pi minus 6. All right, so it's going to be 2 times pi, as the volume is pi, times the integral between 0 and √6. When you subtract them, the line minus the curve, look it up in this. Y squared curve minus y squared line becomes 64 minus 4 is 60. Minus 16x squared. That's smaller. Plus x to the 4th. So that's going to be integrating right there. I'm going to get integral of 60 minus 16x squared plus x to the 4th power dx. That gives the volume. That is 2 times, but each side is the same. So let's go 0 to pi minus 0 to √6. And this is the difference now in those two y squared expressions. All right. This. You can have all of my. All right. So this is what it becomes 2 pi into 60. So you integrate 60. We get this one, we get minus 16x cubed over 3 plus x to the 4 over 5 between √6 and 0. So don't let us space to the 9 marks. Don't let us space. This equals, I'm putting the values now, 2 pi into 60 √6 minus 16 √6 cubed over 3 plus √6 the 4 over 5. I'm going to subtract 0. When I plug 0 everywhere, you're going to get 0. This will give us our answer put in the calculator. Let me see what I get. Put the calculator. Everything here in the calculator. I leave it in terms of pi, so I'm going to leave the pi. So I'm going to get 60 √6. Multiply by 2 afterwards, right? Put it through. It's going to be 2 times bracket 60 √6, 60 times √6 minus at 16 fraction like a fraction the numerator of 16 times bracket root 6 close bracket cubed over 3. Move again, plus fraction bracket root 6 close bracket, that's raised to the power 5 over 5 close that bracket. Let me see if I get the exact answer. Okay, 352 root 6 over 5. 5. Now put that. 352 root 6 over 5. 5 units. Not doing another thing, but make a mistake somewhere. Most students have a calculation. You know that the process is right. Right? When I redo it, sometimes I see this answer is correct. I'm leaving it there, trusting that it is correct. This part makes sense. It says, the diagram below not joined to state show the curve y equals x squared minus 2. That's this one. This is part of the curve. Then y equals x minus 2. And y x minus 2. This says calculate the area of the region enclosed by the curve and the line. This is talking about this here inside here. And it is up to 1 between 0 and 1. Right here is correct, but 2 of them for the ones and 2. Negative 2, so there, negative 2, negative 2. Thing is, this form is going to be 1 minus 1. Let's take like 1 minus 1. 1 minus 2, that is minus 1, yes. And what's here? 1 minus 2 is minus 1. So from this side, 1 minus 1. So what the region, well, the thing is, under the curve, we're going to get a negative area. On the line, we're going to get a negative area. So because the area is going to be negative, one set of lines. So the curve is going to be a bigger area, it's negative. All right, because we measure the area down to the x-axis, right? But it's going to be negative because both are below the x-axis. So watch this now. The area required going to be minus, which is not just to deal with negative. I could have those 10 different between them, you know. I get a negative answer in order to use in the quantity. Right? Just to get the answer right. The area required is equal to minus the area under the curve, area by curve. I'm giving a bigger area, but I'm putting negative to make it turn into positive. Minus area by line. It's negative because those areas are negative. We're going to transpose this negative over here, turn this into positive. So then it becomes the area by the line minus the area by the curve. And similar to what we did about subtract. Remember though, that area is integral of its y dx. Area is the integral of the y dx. And right between the limits of this one, 0 and 1. 0 and 1. And 0 and 1, right? So we have to subtract them again. Line minus the curve. So we can do the subtraction of one and put it out. We can do it one space here. But we have 2 pages. We can finish on this one page with the smaller. And zoom. All right. So the area by the line becomes the integral in 0 and 1. The line equation, which is x minus 2. Dx minus the integral from 0 to 1 within a curve equation now. Curve equation is x squared minus 2. X squared minus 2. X squared minus 2 dx. So minus 2, we have minus the minus 2, then minus 2 gone. So there's x minus x squared and then one integral. So it becomes the integral from 0 to 1 x minus x squared dx. So this is what we're looking at. I'm going to go on the next page. It becomes equal to x squared over 2 minus x cubed over 3 with 1 and 0. That's what we go to say now. It's smaller again. Everything that is, it's not work well. Right here. This becomes equal. Only one is going to apply. It becomes 1 squared over 2 minus 1 cubed over 3. Then you plug in this 0, get 0. Subtract 0. Whatever that answer is in units squared. A mistake in 1 over 3. What are they doing? A half minus a third. Half minus a third. So half is 2 over 6 minus a third is 2 over 6. That is 1 over 6. That's 1 over 6 units squared for the answer. 1 over 6 units squared. That 2 over 6 minus 2 over 6. 1 over 6. That's more here. 1 over 6 units squared. Good. Now it is. Oh, is it in the this says, and that is that. That. So to recap, one question, a little bit of sugar, this one. This is the question we're asking about. Yep. Everything else was just normal, straightforward, no problem. Everything else. Pretty straightforward on this paper. That's what I like to do. Alrighty. Okay. That's another one for the classes. One is easily in class. All right, guys, have fun. Looking at the solution. All right. That is it for tonight, guys. I'm gonna end it now.